Hi everyone and welcome back to my channel Cloud Techs Club. I hope you all are doing well and finding the content helpful. In our Git series so far we have covered an introduction to Git, explored various differences between the CVCS and DVCS version control systems, and also looked into the Git workflow within a repository. We have also discussed few Git features, set up the basic lab environment for the Git, and also explored Git branching, merging, reset options. For more information, take a look at my earlier lectures on the Git. Now let's move forward and deep dive into few more important Git concepts like Git Revert, tagging, along with Git repository cloning to the local machine. So let's first understand what is Git Revert and why we need this. So suppose a developer made a commit in Git repository, but later on realized the code was having a mistake. That's where we have a solution of Git Revert. The Git Revert doesn't delete anything. Instead, it creates a new commit that undoes the changes from previous commit. It's just like saying, hey Git, I messed up back there and let's fix it, by keeping the history. This way your project history stays safe and keep moving forward. Now there is a slight difference when it comes to Git Revert and Git Reset. Git Revert is used after you have made a commit to the local repository and want to undo it in a trackable way, while Git Reset is used before you commit or files within the staging area where you want to completely remove commits from the history. Now let's understand Git Revert with a simple diagram. Just suppose A, B, C, D. Each letter is a commit. You say save change to your one of the projects. Now let's say commit C is having a mistake, but we don't want to mess up with the old history, the commit of A, commit of B, right? So we run a Git Revert on commit C and Git adds a new commit. Let's call it a E. That cancels out what happened while doing the commit for the C. So here's the cool part. So commit E don't delete anything. It just reverses the C's changes and keeps your timeline moving forward. That's why Revert is safe to use in shared or public repositories. Let's go ahead and perform a quick lab for the Git Revert. So I will just check the Git version, whether Git is installed on this particular system or not. Okay, so I will create a directory called test revert. Now I will go inside the test revert. Let's see the contents. Anything is there in this file? No, nothing is there. So I will initialize the Git. So Git is initialized. Let's check the status. Okay, nothing is there. So I will create a file. Let's name it as test git revert, and okay, I forgot this operator. I will write some content into it. First code for Cloud Techs Club. Let's give it Control D. Save contents. Now I will move this particular file from my staging area and to the local repository. This is my first code. Okay, so Let's write some more code within the same file. I'll just give it a test Git Revert, and this is my second code for Cloudtics Club. I'll give it Control D to save it. Let me clear the screen first. Now let's move this again to the staging area in the local repository. Git add, git commit -m. This is my second code. Okay, now I will write my wrong code for testing purpose within this particular Git Revert lab. Test Git Revert. I will say this as wrong code for Cloudtics Club. Control D to come out of it. Let's move this into the staging area, then commit over to the local repository. Commit -m. I will mark it as a wrong code for the identification purpose. Now I have my wrong code and commit is in place. Let's check this with the help of a git status. Nothing is there, and the git log. So here is my wrong code and the commit ID. Now let's perform the git revert on the affected code and the commit, which is this one, right? So git revert and the commit ID of my wrong code. Now it is asking me put something there. Put it like please ignore previous code here. Now what it says after performing the git revert and the commit ID: master revert wrong code, please ignore previous code here, and we saved this particular file. Now let's see what changes occurred after performing the git revert. Cat test git revert file. Okay, now we can see the second code for the Cloudtics Club. So it just moved one step back. Now I will go ahead and see the git log. So you can see here the commit ID, it has generated the new commit ID and it has reverted the wrong code. Please ignore the code here. This reverts the commit, this one. So this was the commit ID which it has reverted. Now let's proceed with understanding tags concept within Git. These are super helpful especially in the real world production environments. You can think of them like a sticky notes or like a labels. You can attach them to a specific commits. It is just like tagging the buckets, so you instantly know what is there inside. This makes it way easier for the teams to mark key pointers into the project's history, like a version releases or the stable builds. It is also helpful in when you need to track or deploy or roll back any particular changes within the production environment. So there are common tag commands in Git which can be used to perform a tag over a particular specific commit. So the command, you can use it as a like git tag with a -a and the tag name and -m and the message and the commit ID. You can also skip the commit ID if you want to tag the latest commit. In case you want to see all the tags, you can just write it a command like a git tag, and to view details about a specific tag, you can just write the git show and the tag name. To delete a particular tag, you can just give it git tag with a small -d and the tag name. So tags are a great way to keep your project organized, especially when you are managing multiple versions or planning the releases. Let's do a quick lab to see how to perform tagging within Git. So I will create a directory test tag. Let's move inside test tag. I will initialize the Git here. Let's create a file, test file 01. I will write the comments. This is my first code for Cloud Tags Club. Control D to come out of it. Now let's move the file to staging area and perform commit to the local repository. Git commit -m first code. Okay, so it has generated a commit ID after committing it into the local repository. Now let's put a tag to this particular commit ID. How to perform it? Git tag -a. I will put the tag of Cloud Tags using the message first code and the commit ID. You can also skip the commit ID if you want to take the latest commit. Otherwise, you can check the output of git log and provide the commit. Okay, I have pasted this 2 times. Okay, so we have put it the tag here. Let's check. So the tag Cloud Tags is now visible. Let's check the more detail about this particular tag. Cloud Tags, git show Cloud Tags. If you want to delete this tag, we can use the command git tag -d Cloud Tags. So deleted tag Cloud Tags. Now let's understand a very small topic of removing untracked files. Sometimes you will notice Git is showing untracked files when you run the command git status. This just means there are files in your workspace or a working directory that Git doesn't recognize. So let's say you create a new file, but you haven't run a Git add on it to move it into the staging area or local repository by commenting it. In that case, Git is not keeping an eye on it. It's just sitting there in your workspace or the working directory. In this situation, Git is just like, hey, I don't know what is this file all about. If you want to remove these untracked files, Git gives you a way to do that. You can use the command git clean -n. It's just like a dry run. This actually shows you the list of untracked files that would be removed, but doesn't actually delete anything yet. So this is just like Git is asking, are you sure you want to delete these files? You want to remove these files? In case you want to proceed further and forcefully delete these untracked files for real, you can use the command git clean -f. So let's go ahead and quickly see this particular concept within the lab to make things more clear. I will create the new directory, untracked files. Let's go inside the untracked files. I will create few files here, touch file 1, file 2, file 3. Let's check. So these files are created. I will initialize the Git here. Okay, now run the Git status. So you can see there are 3 untracked files, the file 1, file 2, file 3. Now let's run the command git clean -add. So you can see would remove file 1, would remove file 2, would remove file 3. So as we discussed, it's just like a dry run. This just shows you the list of untracked files that would be removed, but don't actually delete anything. Now to delete these files, we can use the command the git clean -f. Okay, now it says removing file 1, removing file 2, removing file 3. Let's check the git status again. Okay, nothing is there. So it has removed the files successfully. So the next concept is all about the GitHub cloning. So the term cloning pretty much explains itself. You are making a copy of something. When you clone a GitHub repository, you are basically downloading the whole project from GitHub, a central repository, which we talked about earlier. Or you can say from the central repository to your own local machine or a computer. And it's not just the files, you also get the entire Git history. So you can see everything that has been done to the project so far. So when you clone a repository, you will get all the files and folders in the project, all the branches and the commit history, and also .git folder that lets you use the git commands locally on the system. Now what you can perform on these particular files is you can edit all of them on your local machine. You can create more branches to work on features or fixes. You can commit the changes to them. You can also push them back to the GitHub central repository from your local machine if you have the credentials for doing that. Now let's go ahead and see this quickly within our lab, how we can pull the repository from the GitHub by using the GitHub clone. So this is my GitHub central repository from where I'm going to clone this particular repository, the test 007, to my local machine. So I'm going to copy this link and going to run this command from my local machine, the git clone and the link. So it is cloning whatever is there in this repository from my central GitHub repository to the local machine. So let's see the file here. Okay, so we can see the test 007 here. I will clear the screen. Now let's move inside the test 007 and see the files. So dictionary.yaml, multi-line.yaml, single line.yaml, all 3 files are present. These are the same files which are there within this particular repository on the central GitHub. Let me run this ls-la. So we can see the .git folder as well. That lets you use git commands locally. Let's see the git log. So we can see the commit history as well. So all the files and folders within this project are copied locally within the local machine, and we should be able to see the branches and whatever the commit history was performed within this particular repository, and also the .git folder, which lets you run the git commands locally. So that's it for now. In the next lecture, we will discuss and explore more concepts with other DevOps tools. So stay tuned for the latest videos. Please don't forget to like, comment, and subscribe to the channel. Thank you.